this video we are going to understand the matrix multiplication and division and how we approach this problem. Okay, so this array is given to us, and here for the ith matrix where I starts from 1. Okay, so from the first index the ith matrix has has its order of 40 by 20. Okay, so for the first matrix its order is 40 by 20. For the second matrix its order is 20 by 30, and for the third matrix its order is 30 by 10. So we need to multiply the matrices, combine the matrices into a single matrix by multiplying them, and in the process we need to ensure that we get minimum that we need that we are needed to do minimum number of operations to achieve to achieve the final matrix. Okay, so this is the complete question. So now let's start thinking about it. So suppose this is the array given. Okay, so so it will be very difficult to start to approach this problem head on, like directly from this array. So another way of to think is that our final answer would be a single matrix, right? Now this matrix would be combined by any two matrices. Okay, so these two can only be combined if this has the order of O n and n and n. Okay, so if this matrix has an order of O by n, and this matrix has also an order of n by n or n cross n, then the final matrix will have the order of O cross n. Okay, and the number of operations we would be needed to do in combining these two matrices will be O into n into n. Okay, O into n, O dot O O dot n dot n. Okay, so O n will be the number of operations we will do. Okay, so now let's again think backwards. So how this matrix will come? So if we think casually, then we can think that this matrix will come from the multiplication of few matrices from here, and this matrix will come from the multiplication of the left number of matrices from this array. Okay, so suppose if we take this matrix, and this matrix, we take these three matrices will give their answer as this, and the other left matrices will give their answer as this, and now these two will combine to give this. But if we will go by the rules of multiplication of the matrices, then we should know that the two matrices can only be multiplied if they have their orders in this pattern. Like this, the first matrix, the number of columns the first matrix should have, and the number of rows the second matrix should be equal. Okay, then only they can be multiplied. Also it is given that the the also it is given that at each position we don't have the matrix, but at each position of the array we have some value, right? We have some number, and this number along with the number which is previous to it, it forms an order of the matrix. So these two numbers are for one matrix, these two numbers are for the other matrix, these two numbers are for this matrix. So now this tells us that we cannot arbitrarily combine any we cannot arbitrarily combine this and this matrix or this matrix, right? Here the matrix is coming from the number at this and the number at this position. Okay, so we cannot combine the matrices like this because their orders would not match the pattern for the would not match the pattern for multiplication. Okay, so we need to combine the matrices only in we need to combine the matrices which are consecutive, which are in continuous positions, right? So if so we can only multiply one matrix with only the matrix 2, not with the other matrix, right? Even if some other position has the same number combination, so then also multiplying, so then also combining this matrices this matrix with any other position matrix, if they have the same if they match the pattern, then also it will give the same number of steps to multiply, right? So it doesn't matter. So what the point to really understand here is that the matrix can only be multiplied in sequences, like in the continuous sequence. Like this matrix can only be multiplied with this matrix, like the matrix 1 can only be multiplied with matrix 2, right? Matrix 2 can only be multiplied with matrix 3. The matrix 2 cannot be multiplied with any other matrix like 4 or 5, right? It can only be multiplied with 2 can only be multiplied with either 1 or 3. Okay, so this was the point to understand this. So now this may be coming from the multiplication of these matrices, and these may be coming from the multiplication of these matrices, right? So this forms a very good pattern that we need to understand. Okay, so ON, NM and OM. Okay, so this OM, when we will combine this and this, the number of steps we need to perform will be O, N and M. Okay, and the number of steps we are performing in getting O of N can be can be accessed by the DP table. Similarly here also, the number of operations we were needed to perform in order to get the n cross m matrix will be saved in the DP table. Okay, so we are approaching this problem in top-down approach. Okay, so let's write the recurrence. So so I will write the recurrence and then you will understand it more clearly. This is the code, ignore it for the time's sake, and let's see the results. So what I'm trying to tell is dp of L comma R for the interval L to R, it will be minimum of the minimum it will be like we need to loop over here, we need to loop over on this array, and we need to break it. Like suppose if we break here, then whatever the number of operations here plus whatever the number of operations here plus O and M, across all these breaks we need to take the minimum. Okay, so it will be something like this. for loop I is equal to L I, let's take K. For K is equal to L, K is less than R, K plus plus. Okay, dp of L comma R will be minimum of dp of L comma R comma. So what I'm saying that for O n we will get from dp table this, right? So it will be what, from O to n. So here this means that we will get from dp of L to R minus 1 and L to K plus dp dp of L to K and dp of K plus 1 R plus the number of steps in getting the last matrix, that will be this matrix and this matrix. So one more thing to note here is, like this O of n, if we are combining all the three matrices here, then the order of this matrix will be this matrix, this matrix row into this matrix column, right? Order of this matrix will be this matrix row into this matrix column, right? Why? Because O cross n is here and O cross P is here, then we will get O cross P here, right? And then O cross n and n cross P, so we will get O cross P. And similarly when we will combine here, so O cross P and suppose P cross M, so we will get P cross n, so we will get O cross n, right? So that's what I'm saying. So this is O of n and n of n. So it will be like array position at L minus 1 into array position of K into array position of R. So you can see that O was here, M was here, and O of M. Okay, okay, O of M. So that's what I have done. And L minus 1 means that for the L matrix, the rows will be in the L minus 1 index, right? So that's why I have done it like this. So now here is the row. You can see. So we will call the recursion, save the answer. We need to get the minimum, so we are saving a very big value in answer. Right. This is memoization, and L should be greater than equal to R. So this, when both L and R are at the same index, that means only one matrix is left whose number of columns are at ARR of R position and number of rows are at ARR, whose number of columns are at R index and number of rows are stored at R minus 1 index, right? So when only one matrix is there, then no need to perform any actions. That's why we are returning 0 number of steps we need to perform. Okay, so I hope I was successful in explaining